Now we're going to start with the first lecture on section 2.5, supremum and infimum. So before we started introducing supremum, let's introduce what is it called a maximal. A maximal of a set S is, let S be a set of real numbers. Little m is element of S is a maximum if it satisfies the following property. Is X is a maximum element if m is greater than or equal to x for all x belong to the set S. Okay? Belong to. Okay? All right. So some set have a maximum maximal element and some don't. So what do you mean by that? Let's look at some example, all right? Some don't. For example, 0, 1 has a maximum 1. However, open interval 0, 1 does not have a maximal. Right? Because obviously between 0 and 1, maximal. From 0 to 1, if 1 is included, 1 is greater than all number between 0 and 1, including 1, greater than equals to. However, in the open set 1, which is not including the endpoint 1, we could not find a number that is greater than or equals to any element, all element, not any, all element between 0 and 1. So this set does not have a X maximal. So we want to define differently. So maybe you can you have a maximum of a set, but not necessarily in the set. So here's a formal definition of a supremum. Okay, all right, a number B is an upper bound for a set S if x less than or equal to B for all x belong to S. Okay, let's look at it visually, right, on the right side. So if S is somewhere around here, and any point B, you can be B, any point above that can be an upper bound, right, above that. So this is a set S, okay? So there are many, if a set has an upper bound, then there are many upper bound. However, we said, we call it B sub 0, B null is a, well, maybe not A, is D, least upper bound of S if, first of all, B null is an upper bound. Second of all, B null is less than or equal to a B for any upper bound B. So by definition, right, the least upper bound. So the least upper bound. So if B naught is the least upper bound, if B naught is an upper bound itself, secondly, B naught is less than any other upper bound. So it's called the least upper bound. Okay? So in the above example, okay, 1 is the least upper bound. For both closed interval 0, 1 and open interval 0, 1. Notice that we didn't say B null has to belong to the set. So as long as you can find a number that is what? Less than or equal to all the other upper bound, which is 1 in both cases, okay? Then we call B null the least upper bound. So there's another name for B null, sound a little bit cooler. I don't know about you, but I thought it was pretty cool. Is also called the supremum of the set S, denoted as, we call it sup S. S-U-P-S, sup S. So sup S meaning just the least upper bound. So we might as well introduce, so you have the least upper bound, then the greatest lower bound of the set S, I call it C null, is itself a lower bound, such that C null is greater than equals to C for any lower bound C. So again, we visualize that, right? So you have a set S somewhere around here, and then C null itself is the greatest lower bound, greater than any other lower bound. Okay? As you can see, there's another name for C null as well. C null is also called the infimum of S, and denoted as, we call it inf S. Okay? So the sup of the set open interval 0, 1 equal to 1, even though 1 does not belong to the point 0, 1. Okay? So the inf of 0, 1 equal to 0. All right, so that's the introduction of the two terminology.